Hi, this is a presentation for non-traditional pollution-free energy sources by Sridhar Shah for ITS 102 class, section 03. Here is a list of three non-traditional pollution-free energy sources. OTEG, liquid hydrogen used in aircraft industry, and solar power used with Stirling engine. Now OTEG, what does it mean? It is an acronym for Ocean Thermal Energy Conversion. This technology uses a temperature difference between the cooler and the warmer ocean layers to run a turbine and produce useful work, which is usually in the form of electricity. There can be two possible ways in which energy can be harnessed using this technique. And this leads us to two types of OTEC plants, land-based OTEC, also called onshore, and water-based OTEC, also called offshore OTEC plants. This slide shows the schematic diagram of an OTEC plant, and as the accompanying figure shows, the basic principle of OTEC technology is the temperature difference in water. The surface water gets heated. The surface water gets heated because of the energy from sun's infrared rays and turns into steam. This steam is pressurized enough so that it can turn the attached turbines, which in turn generate electricity. Then steam is allowed to pass through the condensing chamber, which has a cold, deep sea water circulating through its walls, where it gets cooled down and yields desalinated water. Now, the advantages and disadvantages of this system. Um, first of all, that this source of energy is clean and it's green. It has no dependency of fossil fuel, and hence it has potentials to mitigate greenhouse gas emissions which result from burning fossil fuel. Then it's naturally self-renewing source, and it doesn't require any other fossil fuel. And last but not the least, it it produces desalinated water as its end product, which can be used for industrial, agricultural, and residential uses. Now, in the disadvantages column, we can see that it requires substantial capital investment. The minimum capital investment for a small 10 megawatt plant is 50 to 100 million dollars. This shows that it is not highly efficient and highly practical. Then also, the ODAC plants must be located where a difference of at least 20 degrees Celsius or 36 degrees Fahrenheit occurs year-round, which are mostly limited to the tropical waters, and hence this technology is feasible at relatively isolated sites, for example, deep tropical oceans. So it's not quite practical technology. Not, the next slide shows a video clip about a futuristic large-scale source of ocean thermal energy. In technical terms, it's called thermohaline circulation or global conveyor belt.
Circulation, a virtual conveyor belt of water driven by temperature, wind, and the Earth's rotation. Surface water at the equator is heated by the tropical sun. Trade winds created by the same heating effect push this surface water from the Gulf of Mexico towards northern Europe, also known as the Gulf Stream. As the hot upper layer of water moves away from the equator, it cools and evaporates. Water freezes towards the pole, and what's left is very heavy, cold, dense water. This cold, dense water sinks to the ocean floor, pushing its way to the equator, along the east coast of North and South America, and then into Antarctica. This process is referred to as deep water formation. This deep water is pushed out into the Indian and Pacific Oceans, where fresh rainwater dilutes the warming water as it rises. Winds and the Earth's rotation push the water back into the Atlantic where it began. The dark blue indicates the deepest parts of the oceans, where this very cold and very hot water is readily accessible to land, is near the coast of southeast Puerto Rico, at Punta Tuna. Less than 2 miles from the shore, ocean depths drop to more than 3,000 feet deep here, deep enough to access the cold 40-degree water just below the hot 80-degree water necessary for ocean thermal electric conversion, or OTEC.
So that was all about OTEC. Now, let's move on to the next source of energy using that's liquid hydrogen in aircraft industry. It's Reaction Engines Limited A2, which has proposed a new hypersonic airliner. This airliner is intended to provide environmentally friendly, long-range, and high-capacity commercial transportation. It is being examined as a part of LabCat program of the European Union. The plane has not been commercially launched yet, but reaction is limited. The British design firm said it could probably be developed into a working aircraft within the next 25 years if there is a market demand for it. Now, this is a size comparison between the world's current largest aircraft, A360, 380, I'm sorry, A380, and the projected reaction engines limited A2. Now, here's a video clip about this aircraft, and it is supposed to be completely powered by liquid hydrogen.
A2 hydrogen-powered plane. The A2, which is currently entirely a concept, is 100% hydrogen-powered. The only emission is water vapor. It's 2 to 4 times faster than the Concorde ever was, traveling up to Mach 8. It can travel efficiently at subsonic speeds and at hypersonic speeds, which is great if you don't want to wake up all of Europe with your sonic booms in the middle of the night. It's so fast that it could conceivably, flying at top speed, get from New York to Paris in less than an hour. Additionally, to capitalize on the economies of scale, the plane is humongous. It's almost twice as long as Airbus's A380, which is the biggest passenger plane ever to fly. And it'll be able to carry about 300 people. Now obviously the coolest thing about the plane being powered by hydrogen is that the only emission will be water vapor. Right now, a plane trip from New York to LA emits about a ton of CO2 into the air per passenger. That's almost twice as bad as making the same trip in an SUV. So switching over to hydrogen would be pretty amazing. But that's not the only reason why they're interested in using hydrogen. It turns out that per pound, hydrogen can actually carry more energy than jet fuel. And since weight is a pretty important issue on airplanes, that's good news. They're actually saying that for the first time ever, it might be possible to fly a passenger plane from one point on the Earth to any other point on the Earth.
Here are a few facts and figures about this. About its design mission. It is supposed to have a non-stop flight from Brussels to Sydney, via North Pole and Bering Straits. Then it's supposed to cover a distance of 18,700 kilometers, flight time 4.6 hours, payloads 300 passengers, and a few other vehicle parameters, among which the most important is the Mach 8 speed, which means it's gonna fly at the speed 8 times faster than the speed of sound. That's an incredibly high speed. Now, moving to the advantages and disadvantages of this technology, the best advantage is that it yields nothing but H2O as its end product. Burning hydrogen or recombining it with oxygen in a reaction gives off heat, produces just water. Then second advantage is that the energy efficiency of liquid hydrogen is double that of the combustion reaction of the fuel used in current jet airliners. Liquid hydrogen contains about 2.8 times as much energy as jet kerosene on pound-per-pound basis. Disadvantages. The sonic loop generated by traveling at supersonic speed can cause a great discomfort for people on the ground. Liquid hydrogen, the preferred form of hydrogen, requires 4 times the storage space of conventional petroleum-based fuels. The other problem with this technology is that the hydrogen production depends on the availability of a non-renewable resource, petroleum. Currently, hydrogen is produced from raw petroleum for industrial use, but petroleum supplies may become limited in the near future. So that was about using liquid hydrogen in aircraft. So moving on to the next slide, it's about solar power Stirling engine. It is basically a heat engine. It operates on cyclic compression and expansion of air or other gases, which are technically called working fluid. This engine requires 2 different temperatures at its 2 ends, hot, and this difference in temperature is converted into mechanical energy by using the thermodynamical reaction that goes within the piston cylinder assembly. The heat energy transferred into the reciprocating motion of piston gets converted into mechanical energy. That's a basic 19th century Stirling engine. But the 21st century solar power Stirling engine is a bit different. The first point of difference is that in this Stirling engine, they are proposing to use helium, nitrogen, or hydrogen gas as the working fluid. Secondly, instead of using conventional fluid to heat its one end, they're going to use concentrated sunlight.
Now here is a video clip about 3D animation of Tesla Solar Suncatcher. So here are a few advantages and disadvantages of this new technology. In the advantages column, it's low environment effects, sun tracking, lower water usage, range flexible, commercially scalable, and the sun tracking is a new feature over here. Otherwise, the rest are common for solar energy. Sun tracking means the equipment tracks the sun throughout the day and returns to a stored position each evening, ready to repeat the cycle the very next day. This in the disadvantages column, it's the fact that ideally the choice of gas as a working fluid for will be hydrogen for its lightness and its capacity to absorb generated calories. But its ability to diffuse through the materials makes it difficult to keep hydrogen gas sealed within the engine cylinders. Secondly, the fast and effective variations of power are difficult to obtain with a Stirling engine, and hence it is not quite flexible.